For the next 4 videos, which includes this one, we are going to verify whether a given function is continuous at a certain value of z. We have here the first one, we have a linear function, which is also a complex function. F of z is equal to 4z minus 1. And we are to check if it is continuous at z equal to 2 plus I. Notice that our value here is for z, or for the rest of the definition, which stands for z sub 0, okay, is actually expressed as a complex number. We have 2 plus I. Take note that our given function here is linear, and basically it's a polynomial function, or in this case a polynomial complex function, and therefore we have already guaranteed that all polynomial functions are actually continuous at all values of z. But let's try to show it to be true here, given the 3 conditions that need to be met. The first condition is that the limit of our function of z as z approaches to z sub 0, so allow me to use this z sub 0 here instead of z, must exist, okay? Must exist. Because if in the first place, if this doesn't exist, we don't need to proceed to the rest of the 2 conditions, and we just simply say that this is discontinuous, which is actually a negation to the already claimed idea that all polynomial functions are continuous at any value of z. So what can we do here is, of course, to verify whether the limit of your f of z, which is 4z minus 1, as z approaches to z sub 0 exists. Take note, this is actually limit, so we'll be using some limit theorems, or simply by substitution, this is equivalent to 4, the z sub 0, should that be z sub 0, it's actually 2 plus I. So simply substituting that here, so 4 times 2 plus I minus 1, which gives us a value of 8 plus 4I minus 1, if I'm correct. So we have here 7 plus 4I. This is the value of our first condition, and since this is still under the realm of complex numbers, so we have guaranteed that our limit, or the first condition, exists. The second condition that should be met is actually f of your z sub 0. Okay? Take note, it's not all the time that the limit of f of z as z approaches z sub 0 and f of z sub 0 are the same. But basically, we have the same process as we would like to verify if this also exists. So our function earlier was actually 4z minus 1. So our z sub 0 is again 2 plus I. So by substitution, so you will have here f of z sub 0 is 4 times 2 plus I minus 1, which gives us 8 plus 4I minus 1, or you have here the value of 7 plus 4I. Again, a complex number, therefore the second condition also has been satisfied. Now with these 2 already existing, let's proceed to the last condition. Before we can say that this is continuous or not, we need to show that the limit of your f of z as z approaches to your z sub 0 is equal to your f of z sub 0. And we have the value. The answer earlier was 7 plus 4i. This is also 7 plus 4i. So we have guaranteed that they are the same. Now with these 3 conditions already satisfied, then we can say, okay, hence, or therefore you can say, you have here the function f of z equivalent to 4z minus 1 is continuous at z sub 0 equal to 2 plus I. Okay, this has been satisfied because all the 3 conditions have been met. So again, if the first or second condition already been negated or refuted, it doesn't need to proceed to the next few steps. But since all of them are satisfied, we have this final answer. Thank you very much for watching.